Hello friend, and welcome to Science for Sleep. Tonight, we are spending some time with one of the oldest and quietest wonders in the sky. A lunar eclipse does not begin with noise. It does not rush in. It does not tear across the night like a storm. Instead, it begins softly. The moon hangs where it always does, bright and familiar, almost like a steady lantern over the earth. At first, everything seems ordinary. The night looks settled. The sky feels calm. And then, so slowly, that you could miss it if you were not paying attention, the moon begins to change. A faint dimming appears along one edge. Its bright face starts to lose a little of its shine. The change is so gentle that it can feel less like an event and more like a feeling. Then, over time, the moon grows darker still. For a while, it may look as though a shadow is quietly taking a bite out of it. Not a sharp shadow, not a harsh one, but a smooth, curved darkness moving across something that humans have looked at for thousands and thousands of years. And that alone is enough to make the moment feel unusual. Because the moon is one of the most dependable things in the night sky. It changes shape through the month, of course, but it does so in a rhythm people came to know deeply. It rises, it sets, it waxes, it wanes, it returns. It keeps its patterns. So when that familiar moon suddenly begins to darken during a full moon, it feels like the sky has stepped out of line. And yet, one of the strangest parts of a lunar eclipse is this. The moon does not simply disappear. When the eclipse deepens, and the shadow covers more and more of the moon often begins to glow with a dim red or copper color instead. It can look rusty or smoky or ember-like, as if the sky itself has gone warm and quiet for a little while. This is part of what made lunar eclipses so powerful to human beings. They were visible, they were slow, they were beautiful, and they were deeply strange. You did not need a telescope to notice one. You did not need special tools or complicated knowledge. You only needed to look up and see that something old and steady had changed. Long before modern astronomy, people watched the moon and built meaning around it. The moon helped mark time. It shaped calendars. It lit night travel. It watched over farms, rivers, rituals, and sleep. So when it darkened and turned red, people did not treat that as a small thing. They gave it weight. They gave it stories. They gave it fear, reverence, and attention. Some saw warning in it. Some saw mystery. Some saw a sign meant for kings or nations or the whole world. And over time, others began to do something just as powerful. They watched more carefully. They noticed that the shadow crossing the moon was curved. They noticed that eclipses followed patterns. They noticed that the event was not random, even if it felt that way at first. Little by little, what once seemed like a break in the order of the sky began to reveal a deeper order instead. That is one of the quiet wonders of a lunar eclipse. It is beautiful enough to stir the imagination, but precise enough to teach us something real. This changing moon to help people understand the shape of Earth. It helped sky watchers notice repeating cycles. It helped turn fear into record keeping, and record keeping into prediction. So tonight, as we follow the moon into shadow, we are not only looking at an eclipse. We are looking at one of the oldest shared experiences in human history. We are looking at a sky event that frightened people, fascinated them, guided them, and slowly taught them. And the more closely we look, the more it begins to feel like both a scientific story and a human one, unfolding at the same time under the same dark sky. But before anyone understood shadows or alignment, or the reason the moon could darken and glow, there was a simpler and older feeling. People looked up, saw the familiar moon begin to change, and had to ask themselves what on earth was happening. For most of human history, the sky was not just a backdrop. It was a source of rhythm, comfort, warning, and meaning. The sun told people when to work. The stars helped guide direction. And the moon was one of the most steady and familiar lights in the world. It changed shape, yes, but it changed in ways that people could learn. It followed a pattern. It returned. It could be trusted. So when that trusted moon suddenly began to darken, it did not feel small. It felt like something had interrupted the natural order of things. That reaction makes a lot of sense. A lunar eclipse is easy for us to explain now, but for very early people, there was no reason to assume the event had a simple physical cause. If the moon gave light and order to the night, then a darkened moon could feel like a sign that something was wrong. And because human beings are meaning-making creatures, people did what people have always done. They tried to understand the event in human terms. They asked whether something was taking the moon away. They asked whether a spirit, a god, or a creature was involved. They asked whether the darkening meant danger for a village, a ruler, or the land itself. When something rare happens in the sky, it does not stay only in the sky. It enters people's emotions. It enters memory. It enters story. That is one reason eclipses became so important in human culture. They were not only seen, they were felt. A normal full moon can be beautiful, but it also becomes familiar. A lunar eclipse is different. It begins with familiarity and then slowly turns unfamiliar right in front of your eyes. That kind of change is powerful. It holds attention. It makes people stop what they are doing. It creates a feeling that the world is briefly less stable than it seemed a moment ago. And because the event happens slowly, there is time for that feeling to build. The moon does not vanish in an instant. It dims little by little. A shadow spreads. The color changes. The longer it lasts, the more it invites questions. What is doing this? Why now? What does it mean? For ancient people, those were not silly questions. They were reasonable questions asked in a world where the sky was closely tied to life on Earth. If crops depended on the seasons, and the seasons depended on the heavens, then a strange change in the heavens might seem important. If rulers were believed to stand in a special relationship with the cosmos, then an eclipse might seem aimed at them. If the moon shaped ritual, timekeeping, or night travel, then its sudden darkening could feel like more than a curiosity. It could feel personal. That is why many cultures responded to eclipses actively rather than passively. People prayed. People watched closely. People performed rituals. People made noise. People treated the event as something that demanded a human response. Even without writing, early humans likely would have remembered eclipses well. A strange night sky is the kind of thing a community talks about. It becomes a story told again later. It becomes part of the shared memory of a place. And over time, these memories became traditions. Different cultures imagined different causes, but many of those ideas had something in common. They treated the eclipse as a struggle, an attack, a swallowing, or a warning. In other words, they treated the darkening moon not as a quiet shadow, but as an event with intention behind it. That may sound distant from the modern view, but in another sense, it is very close to us. Even now, when something surprising happens, the human mind wants a cause that feels immediate and alive. We are drawn to story before we are drawn to geometry. We notice drama before we notice alignment. The difference is that today we have had a very long time to compare, record, and explain what earlier people could only witness. And what they were witnessing was real enough to deserve all that attention. Because the moon really was changing. It really was darkening. It really was turning strange. It really was asking to be noticed. The only difference is that what felt like an interruption from outside was actually something quieter, more regular, and more beautiful than that. It was not a beast. It was not a wound. It was not the sky breaking apart. It was Earth itself, moving into just the right place, casting its shadow across the face of the moon. A lunar eclipse may feel mysterious when you watch it, but the event itself is built from something very simple. It is a matter of light, motion, and position. The sun is shining. The Earth is moving through space. The moon is traveling around Earth. And for a little while, all three line up in just the right way. A lunar eclipse happens when Earth moves directly between the sun and the moon. That means sunlight, which normally reaches the moon and lights it up, is blocked by Earth instead. The moon passes into Earth's shadow, and from the ground, we begin to see that shadow slowly spread across the lunar surface. That is the basic shape of the event. The sun is on one side. Earth is in the middle. The moon is on the far side. This is why a lunar eclipse can only happen during a full moon. A full moon already means the moon is opposite the sun in our sky. The sun is lighting the whole face of the moon that we can see. So if Earth is going to block that sunlight, the moon has to be in that full moon position to begin with. In other words, the setup is already halfway there. The bright full moon is not just a pretty backdrop for the eclipse. It is one of the conditions that makes the eclipse possible. That also helps explain why the event looks the way it does. On a normal full moon night, sunlight travels to the moon, reflects off its surface, and then reaches our eyes here on Earth. The moon is not making its own light. It is shining because it is lit. During a lunar eclipse, that direct path of sunlight is interrupted. Earth gets in the way. And because Earth is much larger than the moon, the shadow it casts into space is wide enough for the moon to move through it gradually, rather than all at once. That is part of why a lunar eclipse feels so slow and calm. The moon is not being switched off. It is passing through a large shadow step by step. At first, the change can be hard to notice. The outer part of Earth's shadow is faint and gentle. As the moon begins to edge into that softer shadow, its brightness may seem a little muted, almost as if someone has turned down the light very slightly. Then, if the alignment is deep enough, the darker part of the shadow begins to take hold. That is when the eclipse becomes much easier to see. A curved darkness starts moving across the face of the moon, and the change feels more obvious with each passing minute. So even though the event looks dramatic, it is really the result of a very quiet piece of celestial timing. Nothing is rushing, nothing is colliding, nothing is being attacked. The moon is simply continuing along its path, and Earth is simply standing in the light. That is one of the beautiful things about astronomy. A scene that once inspired fear can, when understood, feel even more elegant. The eclipse is not random. It is the natural result of a system that is always in motion. The moon orbits Earth. Earth orbits the sun. Light travels outward. Shadows form when something blocks that light. A lunar eclipse is what happens when all of that becomes visible to us in a single event. And because the moon moves through Earth's shadow in stages, the eclipse can take on different forms. Sometimes only a small part of the moon enters the darkest shadow. Sometimes the whole moon does. Sometimes the change is faint, and sometimes it is unmistakable. But all of those versions begin with the same basic arrangement. Sun, Earth, moon, light blocked, shadow cast. What once felt like a disturbance in the sky turns out to be a kind of cosmic alignment. A moment when the usual movements of the Earth and moon reveal themselves in a way we can actually watch. Still, one important question remains. If a lunar eclipse needs a full moon, and full moons happen every month, then why do most full moons pass by in their usual bright and peaceful way, with no eclipse at all? Long before modern observatories, long before telescopes, and long before people spoke about orbital tilt or atmospheric filtering, there were already human beings watching the sky with deep seriousness. In ancient Mesopotamia, especially in Babylon and Assyria, the heavens were not treated as decoration. They were watched, they were recorded, they were interpreted. The moon mattered greatly in these early civilizations. It helped shape calendars, mark time, and organize life. So when a lunar eclipse appeared, it was not seen as a passing curiosity. It was treated as an event with meaning. Mesopotamian skywatchers were among the first people we know of who wrote down eclipse observations in a systematic way. On clay tablets, they recorded what they saw and compared it to lists of omens and earlier observations. These records did not sound like modern science, but they do show something very important. People were paying close attention. They noticed when the eclipse began. They noticed where on the moon the darkness first appeared. They noticed how long it lasted. They noticed the direction of the shadow and the part of the sky where the moon stood. To them, these details were not minor. They mattered because eclipses were often connected to kings, kingdoms, and the future of the state. A lunar eclipse could be read as a warning to a ruler. It could be taken as a sign of danger, instability, or change. In some texts, the meaning of the eclipse even depended on where the shadow began or how the eclipse cleared. A darkened moon was not just a strange sight. It was something to be interpreted carefully. That may sound distant from the modern way of thinking, but there is another side to it that feels surprisingly familiar. The Babylonians did not only fear eclipses, they studied them. This is one of the reasons Mesopotamia matters so much in the story of lunar eclipses. These early records stand near the place where human anxiety begins to turn into long-term observation. The event still carried omen language, but underneath that language was something else quietly growing. Memory, comparison, pattern. Each eclipse added to a larger body of watching. And as that body of watching grew, people could begin to notice that lunar eclipses were not random in the way they first seemed. They belonged to the sky's larger order. They returned. They followed conditions. They fit into rhythms, even if those rhythms took generations to understand clearly. Mesopotamian observers also lived close to one of the most basic facts of lunar eclipses, even if they explained it differently from us. A lunar eclipse happens only at full moon. That would have been clear to anyone who kept careful records. The moon had to be fully lit before it could be dramatically darkened. You would not see this kind of event on a thin crescent or a half moon. The eclipse belonged to the full moon, and that link alone would have made the full moon feel even more important. But that raised a quiet puzzle. If eclipses belong to the full moon, then why do they not happen every full moon? That question would have taken much longer to answer. Still, the very act of asking it shows how close these early observers were coming to a deeper kind of astronomy. Once you start comparing many full moons to the smaller number of actual eclipses, you begin to sense that something more specific is going on. Not every full moon is enough. Something else has to line up. Some additional condition has to be met. That is where eclipse watching becomes so interesting in human history. At first, the eclipse feels like a warning from the sky. Then it becomes a record. Then, slowly, it becomes a clue. The people of Mesopotamia may not have had our modern explanation, but they helped create one of the habits that made that explanation possible. They looked up, wrote things down, compared one event to another, and treated the sky as something worth remembering. So in the shadowed moon above them, they were seeing more than a sign for kings. They were also, without fully knowing it yet, looking at one piece of a repeating celestial pattern. And the more carefully people watched that pattern, the more clearly they began to see that the full moon alone was not enough. A lunar eclipse begins to make sense very quickly. The Earth moves between the sun and the moon. The moon passes into Earth's shadow. The bright full moon begins to darken. That part feels simple enough. But almost as soon as people understood that much, another question would have followed. If the moon becomes full every month, then why does it not slip into Earth's shadow every month too? It is a very natural question, because on the surface, it seems like it should happen all the time. A full moon means the moon is on the far side of Earth from the sun. That is already the basic arrangement a lunar eclipse needs. So why do most full moons rise bright and peaceful, with no shadow crossing them at all? The answer is that the moon's path around Earth is not perfectly lined up with Earth's path around the sun. It is slightly tilted. That tilt is small, only about 5 degrees. But in astronomy, a small tilt can make a very big difference. To picture this, it helps to imagine two great circular tracks in space. One track is the path Earth follows around the sun. The other is the path the moon follows around Earth. If those two paths were laid exactly on top of each other, then every full moon would bring a lunar eclipse, because the moon would pass straight through Earth's shadow every single month. But that is not how the system is arranged. The moon's orbit is tipped a little compared with Earth's orbit. So most of the time, when the moon becomes full, it passes a little above Earth's shadow or a little below it. The alignment is close, but not close enough. The moon is full. The Earth is in the middle, but the shadow and the moon do not meet. They miss each other. And that quiet little miss is why most full moons remain ordinary. This is one of the reasons lunar eclipses feel special. They are not just full moons. They are full moons that arrive at exactly the right place in the moon's tilted path. There are 2 points in the moon's orbit where its path crosses the flatter plane of Earth's path around the sun. These crossing points are especially important because they are the places where the moon can line up properly with Earth and the sun. If a full moon happens when the moon is near one of those crossing points, then the moon can enter Earth's shadow and a lunar eclipse can occur. If the full moon happens too far away from one of those crossings, there is no eclipse. The moon still looks full. It still rises beautifully. It still follows its usual rhythm. It just stays outside the shadow. So the full moon is necessary for a lunar eclipse, but it is not enough on its own. The moon must also be in the right part of its orbit. That detail matters because it reveals something deeper about the sky. A lunar eclipse is not simply a result of the moon being full. It is a result of precision. It depends on timing, angle, and position all working together. And that would have been one of the most interesting things for ancient observers to notice, even before they could explain it the way we do now. They would have seen that eclipses belong to full moons. That much would have been clear. But they also would have seen that many full moons passed with no eclipse at all. That meant the event had rules. It was not random. It was not happening whenever it pleased. Something more exact was controlling it. That realization may have been subtle, but it was powerful. Once you notice that a strange event does not happen at just any time, you begin to sense that the heavens have structure. The sky may still feel mysterious, but it no longer feels careless. It begins to feel ordered, even if the order is not fully understood yet. And that is one of the quiet beauties of a lunar eclipse. What first looks like a disruption is actually a sign of deeper regularity. The moon is not wandering into danger. The sky is not breaking pattern. The system is following pattern very closely. In fact, lunar eclipses are rare enough to feel meaningful, but regular enough to be studied. That balance is part of what made them so important in human history. They were uncommon, so people remembered them. But they were not so rare that no pattern could ever be found. With enough patience, enough recording, and enough generations of watching, the hidden rhythm could begin to emerge. So the reason there is not a lunar eclipse every month is not that the full moon is unreliable. It is that the moon moves through the sky on a path that is slightly tipped. Most months, that tipped path carries it safely above or below Earth's shadow. Only now and then does the full moon arrive in just the right place to enter the shadow fully. And when it does, people see something even more revealing than the eclipse itself. They see the shadow crossing the moon in a smooth, curved line. As the eclipse deepens, the eye is drawn back to the moon itself. The change is slow enough to watch closely. Little by little, the bright face of the full moon begins to lose its familiar shape. A dark edge moves across it. But what stands out most is not just the darkness. It is the form of that darkness. It does not look rough. It does not look torn. It does not look random. It looks smooth and curved. That curved edge is one of the quietest and most important details in the whole event. During the partial phase of a lunar eclipse, when only part of the moon has entered Earth's deeper shadow, The darkened portion often looks like a round bite has been taken from the moon. The line is gentle and even, almost like the edge of a circle slowly sliding across another circle. This makes the eclipse feel calm, but it also makes it feel precise. The shadow is not spreading like smoke. It is not flickering like a cloud. It has shape. It moves with patience. It stays consistent. And for people who watch closely over long stretches of time, that consistency became very hard to ignore. To understand why the shadow looks this way, it helps to picture Earth's shadow as having two parts. The first is the penumbra. This is the lighter outer part of the shadow, where Earth blocks some sunlight, but not all of it. When the moon first enters this region, the change can be subtle. The moon may look a little dimmer, a little duller, as if someone has lowered its brightness very gently. If you were not paying attention, you might miss that first stage entirely. Then comes the umbra. The umbra is the deeper central part of Earth's shadow, where the sun's direct light is blocked much more fully. When the moon begins to enter the umbra, the eclipse becomes much easier to see. This is when the darker bite appears. This is when the curved shadow starts to look bold and unmistakable against the bright lunar surface. So in a way, the penumbra whispers, and the umbra speaks more clearly. The penumbra softens the moon. The umbra reshapes it. And that reshaping is what made such a strong impression on careful observers. Again and again, eclipse after eclipse, the same thing appeared. A rounded shadow moved across the moon. That repeated curve mattered. It mattered because nature does not always give such clean clues. Many things in the world are irregular. Mountains are jagged. Clouds change shape, fire flickers, but the eclipse shadow kept arriving with a smooth edge, as though it belonged to something solid and round. This is part of what makes a lunar eclipse more than just a beautiful sight. It becomes evidence. Even before anyone had a full modern picture of the solar system, people could still observe what was in front of them. They could notice that Earth's shadow, cast onto the moon, always seemed curved. Not sometimes curved, not occasionally curved, consistently curved. That is a very suggestive detail. If the Earth were some strange flat shape, or a body with a more irregular form, the shadow it cast might not always look so neatly round. But during lunar eclipses, the shadow crossing the moon kept offering the same quiet hint over and over again. Something round is making this shape. Of course, not everyone would have thought of that immediately. For many people, the eclipse remained a powerful event first and an intellectual clue second. But once human beings began comparing observations and asking geometric questions, the curved shadow became more than just a passing visual feature. It became a clue hidden in plain sight. And there is something lovely about that. A person could step outside, look up at the darkened moon, and be seeing not only a rare event, but an outline of the Earth itself. Not directly, not all at once, but through its shadow. The moon, for a little while, became a kind of screen, and on that screen, the Earth was leaving a mark. That mark moved slowly. It stayed curved. It stayed orderly. And for some of the thinkers who came later, that was enough to begin drawing a much larger conclusion. That shadow was more than a passing darkness. For Greek thinkers, it became a clue about the shape of the world itself. In ancient Greece, some thinkers began asking not only what the sky meant, but how it worked. That shift mattered. For a very long time, unusual events in the heavens had been treated mainly as signs, warnings, or messages. And for many people, they still were. But among certain Greek thinkers, another habit was growing alongside wonder. They wanted causes, they wanted patterns, they wanted explanations that fit the world in a more physical way. A lunar eclipse was perfect for that kind of thinking. It was visible, it was memorable, it repeated, and it showed the same strange features again and again. One of the most important early figures in this change was Anaxagoras. He lived in the 5th century BCE, and he is often remembered as one of the thinkers who tried to explain celestial events in natural rather than purely mythic terms. He understood that the moon does not shine with its own light, but reflects the light of the sun. That was a major step. Once you understand that the moon is lit by sunlight, a lunar eclipse begins to make more sense. If something blocks that sunlight, the moon will darken. That idea sounds simple now, but it changed everything. It turned the moon from a mysterious glowing body into something that could be understood through light and shadow. It also meant that an eclipse was not a wound or a devouring. It was an event of alignment. The sun lights the moon. The earth gets in the way. The moon falls into shadow. That kind of explanation does not remove wonder. It simply gives the wonder structure. And then there was Aristotle. A little later, Aristotle wrote about the Earth's shadow on the moon during lunar eclipses, and he noticed something that would become one of the most famous clues in the history of astronomy. The shadow crossing the moon was always round. That observation carried real weight. If the Earth were flat like a disc, or shaped in some more awkward way, then its shadow might not always appear curved in the same way. A flat object can cast different shadows depending on its angle. But a sphere has a special quality. No matter how it is turned, its shadow remains circular. So when Greek thinkers saw that curved shadow appearing again and again during lunar eclipses, they had reason to think that Earth itself must be round. It was not the only clue they had. Travelers also noticed changes in the stars as they moved north or south. The way ships vanished hull first over the horizon also suggested curvature. But the lunar eclipse offered a particularly elegant kind of evidence. It let the Earth reveal its shape from a distance, through shadow alone. That is one of the beautiful things about this moment in history. People were looking at the moon, but learning about Earth. They were watching darkness cross a familiar object in the sky. And from that darkness, they were drawing a conclusion about the world beneath their feet. A rare event had become a geometric hint. And that is why this part of the story matters so much. The eclipse was no longer only a symbol. It was no longer only a fear. It had become an argument, a visible one, a repeatable one, a quiet one. This was part of a larger Greek habit of thought, where observation and reasoning began to work together more deliberately. The heavens were still grand and mysterious, but they were also lawful. They could be studied. Their patterns could be used to say something true about reality. That does not mean everyone in Greece agreed on everything, or that older symbolic meanings vanished overnight. Human understanding never changes that cleanly. Myth and reason often live side by side for a long time. But what matters here is that lunar eclipses helped open a door. They showed that careful observation of the sky could lead to a real conclusion about the shape of the Earth. And that is a remarkable thing. A person could stand under a darkening moon, watch a curved shadow move across it, and see not just a celestial event, but evidence. The night sky, which had once seemed to act from will or mood, was beginning to look more like a system with light, motion, shadow, and form. The eclipse still had power. It still felt strange. It still held the eye. But now it also carried explanation. And even with that explanation in place, one part of the event still seemed almost magical. If Earth blocks the sun's light, then why does the moon not simply disappear into blackness? Why, at the deepest part of the eclipse, does it so often begin to glow red? At the deepest part of a lunar eclipse, something surprising happens. The moon does not simply vanish. If Earth is standing between the sun and the moon, and if Earth is blocking the sunlight that normally lights the lunar surface, then it would seem reasonable to expect the moon to go dark. Not dim red, not copper, not rust-colored, just dark. But that is not what usually happens. Instead, as the eclipse deepens and the moon moves fully into Earth's central shadow, the bright silver moon often takes on a new kind of light. It may glow faintly orange. It may look deep red. It may seem brownish, smoky, or ember-like, as if the sky has left a warm stain across its surface. This part of the eclipse has always felt especially mysterious. And yet the reason is one of the most beautiful in all of astronomy. The answer lies in Earth's atmosphere. Even though Earth blocks the sun's direct light, our planet is surrounded by a blanket of air. And that air does not simply sit there unnoticed during an eclipse. It bends light. It filters light. It changes what kind of sunlight can pass through and continue into the shadow. Sunlight may look white at first glance, but it is really made of many colors. And those colors do not all move through the atmosphere in the same way. Shorter wavelengths, especially blue light, are scattered more strongly by the gases and tiny particles in the air. That is why the daytime sky looks blue. Blue light is being scattered in many directions. Red and orange light, by contrast, pass through the atmosphere more easily. So during a lunar eclipse, as sunlight skims through the edges of Earth's atmosphere, much of the blue light is scattered away. What continues onward into Earth's shadow is richer in red and orange tones. Some of that light is also bent slightly by the atmosphere, curving into the shadowed space behind Earth. And that bent, filtered light reaches the moon. So even at the moment when the moon is deep inside Earth's shadow, it is not receiving no light at all. It is receiving a very special kind of light. Light that has passed through the edge of Earth's atmosphere. Light that has been thinned of its bluer colors. Light colored by the same process that gives us red sunsets and orange dawns. In a way, the eclipse moon is being lit by the ring of all the world's sunrises and sunsets at once. That is why the color can feel so haunting. The moon is not glowing on its own. It is reflecting sunlight that has been softened, filtered, and reddened by the air surrounding Earth. The eclipse turns our own atmosphere into part of the performance. This is also why the phrase blood moon can be a little misleading if it sounds like a different kind of moon. It is not a separate object. It is not a special moon in itself. It is simply the appearance a totally eclipsed moon often takes on. The term points to the color, not to a different kind of lunar body. And not every eclipsed moon looks exactly the same. Some are bright copper, some are darker red, some lean more brown or grayish red. But the general reason remains the same. Earth is blocking the direct sunlight, while its atmosphere is still letting some warmer colored light bend into the shadow. This is one of those rare explanations that makes the event feel even more beautiful, not less. The red moon is not a trick. It is not an illusion. It is not a sign that something has gone wrong in the sky. It is a visible reminder that Earth is present in the scene. The moon is carrying a kind of atmospheric fingerprint from our own planet. During the eclipse, the moon becomes a distant screen for Earth's filtered light. Of course, for most of human history, nobody would have explained it this way. People saw the color first. They saw the moon grow dark, then reddish, then strange. And once that happened, it was almost impossible not to give the sight a deeper meaning. A red moon invites symbolism very naturally. It can look wounded. It can look threatened. It can look like a warning. Even today, the color alone can stir something ancient in the imagination. So while the explanation is gentle and physical, the feeling it creates is still powerful. A red moon is easy to explain with atmosphere and light. But long before that was known, it had to mean something. And in many places, it meant a great deal. Once the moon darkened and turned red, people did what human beings have always done with rare and powerful things. They gave the moment a story. A lunar eclipse was too unusual to feel empty. It did not seem like the kind of event that could simply happen without meaning. The moon was familiar. It was dependable. It kept its patterns. So when that familiar full moon began to dim, and then glowed with a red or copper light, many people felt that something larger had to be taking place. And in culture after culture, the same kinds of images began to appear. Something was swallowing the moon. Something was attacking it. Something was wounding it. Something in the sky was struggling against something else. These ideas showed up in different forms, but they often shared the same feeling. The eclipse looked like a disturbance in the natural order, and human beings reached for the language of conflict to explain it. That makes a great deal of sense. When something bright and complete is slowly covered, it can look as though it is being eaten away. When it turns red, it can seem injured or bloodied. The event unfolds gradually enough that the imagination has time to work on it. A person standing under that sky would not simply see a changed moon. They might feel as though they were witnessing a crisis. That is why myths about eclipses so often involve devouring creatures, cosmic enemies, or moments of danger. In some traditions, a beast, dragon, serpent, or demon is said to be consuming the moon. In others, the eclipse becomes part of a larger struggle between heavenly powers. Sometimes it is understood as a warning for rulers or whole nations. Sometimes it calls for ritual action to help restore order. What matters most is not the exact shape of every story, but the pattern beneath them. Again and again, human beings treated the eclipse as a moment when the sky itself seemed vulnerable. And because the moon was so widely tied to time, cycles, fertility, night travel, and spiritual order, Its darkening could feel personal as well as cosmic. The event was not only above people, it reached into their sense of how the world should behave. That is one reason many communities responded actively. They prayed, they performed rituals, they made noise, they gathered together. They treated the eclipse as something that demanded attention. Noise appears especially often in eclipse traditions. In some places, people beat drums, shouted, or clanged metal objects in an effort to frighten away whatever was believed to be attacking the moon. Even if the exact beliefs differed, the action itself tells us something important. People did not want to stand by and do nothing. The eclipse invited participation. It created a feeling that human beings should respond to what they were seeing, as though the balance of the sky and the balance of earthly life were linked. The red color of the moon added even more force to these interpretations. A pale moon becoming dark is already striking. A pale moon becoming red is something else entirely. Red is one of the most emotionally charged colors in human experience. It can suggest blood, danger, warning, anger, heat, sacrifice, or power. So when the eclipse moon took on that color, it was almost unavoidable that people would connect it to ideas of injury, danger, or divine emotion. That does not mean these myths were foolish. It means they were human. They were attempts to make sense of an extraordinary sight using the tools available at the time. Memory, symbol, feeling, ritual, and shared story. In many ways, myths did what science also tries to do. They gave shape to confusion. They help people place a strange event inside a larger understanding of the world. The difference is that myth explains through meaning, while science explains through cause. And for a long time, the two can live side by side. Even in cultures where eclipse myths were strong, people still observed the event carefully. They remembered it. They recorded it. They compared one eclipse to another. So the story of lunar eclipses is not a simple march from superstition to truth. It is more layered than that. Human beings felt the eclipse emotionally, gave it symbolic weight, and at the same time slowly began to notice that it followed patterns. That is part of what makes the history so rich. The moon could be feared and studied. It could be narrated and measured. It could be sacred and observable at once. And in some places, that careful observation became a state responsibility. In ancient China, especially, eclipse watching was not only cultural or spiritual. It became something official, recorded, and tied to the order of the world. In ancient China, eclipses were not treated as small curiosities drifting through the night. They were taken seriously, very seriously. A change in the sky could be understood as a change in the order of things. The heavens were closely linked to earthly rule, so unusual celestial events were often treated as warnings, signals, or moments requiring careful attention. A lunar eclipse was not only something to look at, it was something to respond to. That gave eclipse watching an official weight. In many cultures, people watched the moon because it was beautiful, useful, or mysterious. In China, those things were true as well. But eclipse watching also became part of the responsibility of the state. To watch heaven closely was, in a sense, part of governing well. This long tradition reaches back very far. Chinese records of eclipses stretch deep into antiquity, into the Shang and Zhou periods and beyond. Some early inscriptions and later texts preserve a world in which celestial events were carefully noted, remembered, and tied to larger concerns about order, legitimacy, and fate. The language could be vivid. An eclipse might be described as the moon being eaten or attacked. The image is dramatic, but it tells us something important about how the event felt. A bright, whole moon did not simply dim. It seemed to be overtaken. And if the heavens were a mirror of proper balance, then such a disturbance could not be ignored. For rulers, this mattered especially. An emperor was not imagined as separate from the order of heaven. So when an eclipse appeared, it could be interpreted as a warning directed toward the throne, the court, or the realm itself. That did not mean every eclipse caused panic, but it did mean the event carried political and ritual meaning. It belonged to the world of governance as much as the world of stargazing. That is part of what makes ancient China so important in the story of lunar eclipses. The event remained symbolic, but it also became administrative. People recorded it. Officials tracked it. Rituals surrounded it. The state paid attention. Ceremony often followed. Sources describe ritual responses that could include drumming, official observance, and formal acts meant to acknowledge the disturbance in the heavens. In some traditions, noise was made to respond to the threat imagined in the sky. In others, the court marked the event with seriousness and restraint. What matters most is that the eclipse was not treated casually. It entered public life, and that public attention encouraged careful records. Once a culture begins writing down celestial events over long stretches of time, a quiet transformation begins. Fear may still be present. Symbolism may still be strong, but another layer starts to grow underneath them. Comparison. One eclipse can be a shock. 10 eclipses, carefully noted, begin to create memory. 100 eclipses, preserved across generations, begin to reveal pattern. That is where ancient Chinese eclipse history becomes especially powerful. The records did not only preserve emotion, they preserved repetition. Over time, observers could compare one event to another, noting when eclipses happened, how they appeared, and how they fit into larger celestial rhythms. This did not mean the old meanings vanished. It meant they were joined by something else. Careful watching. The sky was still full of signs, but it was also beginning to look lawful. The more often a phenomenon returns in ways that can be tracked, the harder it becomes to see it as pure chaos. It still may be important. It still may feel ominous. But it also begins to look ordered. That is one of the deepest themes in the story of eclipses. Human beings first feel the event, then they name it, then they record it, then slowly they notice that it repeats. Ancient China stands beautifully inside that process. The eclipse could still be treated as a warning for rulers, still call for ritual attention, and still belong to a cosmos filled with meaning. Yet at the same time, it could also become part of an increasingly systematic tradition of observation. That balance is what makes these records so rich. They preserve a world where the heavens were alive with importance, but also a world where patient record-keeping slowly made prediction possible. And once prediction begins to enter the story, something subtle changes in the human relationship with the sky. The eclipse is still powerful, but it is no longer only a surprise. The more often people recorded eclipses, the the harder it became to see them as purely random. Patterns began to appear in the darkness. A single lunar eclipse can feel like a disruption. It appears, it unsettles, it passes. But when the same kind of event is seen again, and then again after that, something begins to change in the human mind. The eclipse is still striking, still memorable, still strange to watch, but it is no longer completely alone. It begins to belong to a family of moments, and once that happens, the sky starts to feel a little different. It starts to feel less like a place of isolated surprises and more like a place of repeating patterns. This is one of the quiet turning points in the history of astronomy. Human beings did not first understand the heavens by solving them all at once. They understood them by noticing, by remembering, by comparing, by letting one event sit beside another until similarities began to appear. A lunar eclipse was especially good for this kind of noticing. It was dramatic enough to be remembered, rare enough to stand out, and regular enough over long stretches of time to return. That combination mattered. A person might see one eclipse and feel fear. A community might see several and begin to tell stories. But a culture that writes eclipses down, carefully and repeatedly, begins to do something more. It builds a long memory of the sky. That long memory changes everything. Once records exist across years and generations, observers can begin asking new kinds of questions. Does the eclipse happen at the same phase of the moon each time? Does it tend to return after certain intervals? Are there similarities in how long it lasts, how dark it becomes, or where in the sky it appears? These are small questions at first. But small questions asked patiently often lead to large discoveries. Ancient sky watchers did not begin with modern physics. They did not have telescopes, computer models, or equations of motion written in the form we know today. But many of them had something just as important at the beginning: patience. They looked. They remembered. They wrote things down. They compared one generation's observations with another's. That is one of humanity's greatest quiet strengths. Pattern recognition does not always arrive with a grand announcement. Sometimes it comes from simply refusing to let a rare event be forgotten. So eclipses slowly moved from signs to sequences. That does not mean the older meanings vanished right away. A lunar eclipse could still feel ominous. It could still be wrapped in story, ritual, or political meaning. But alongside that older layer, another layer was growing. The eclipse was becoming something trackable. And once an event becomes trackable, it becomes less lonely. It becomes part of a rhythm. You can almost imagine how this shift felt. At first, the eclipse arrives like an interruption. Then later, someone remembers that something like this happened before. A record is checked. A tablet or text is compared. The details are not identical, but they are close enough to stir recognition. The sky has done this before. That realization is powerful. It suggests that the heavens are not acting on impulse. They are repeating themselves. Not perfectly in the simple sense, but with enough order to reward memory. And in that moment, the eclipse stops being only a shock from above. It starts becoming evidence that the sky itself has structure. This is where astronomy begins to deepen. Not with certainty yet, not with complete explanation, but with rhythm. a rhythm seen through scattered events, a rhythm built from decades of watching, a rhythm that could only be found by people willing to care about what happened long ago. That care made later discoveries possible, because once enough eclipse records had been gathered, observers could begin to notice that eclipses did not return at random times. They seemed to recur in patterns that stretched across many years. One eclipse might resemble another from long before. A kind of family likeness began to emerge. And that is one of the loveliest things about this stage of the story. The darkness itself became a teacher. Each eclipse left behind more than memory. It left behind a clue. The next eclipse added another clue. Slowly, quietly, over generations, human beings pieced those clues together until the sky began to reveal one of its deeper habits. Lunar eclipses recur in cycles. That discovery did not arrive all at once, and it did not belong to one single moment. It grew out of long attention. But once people recognized those repeating families of eclipses, they had a new way of seeing the heavens. Not just as a place of meaning, not just as a place of warning, but as a place of recurrence. Those repeating families of eclipses eventually gained one of astronomy's most famous names, the Saros cycle. There is something uniquely human about the Saros cycle. It is not a machine you can hold in your hand. It is not a bright object in the sky. It is not even something a single person would likely discover alone in one lifetime. It is a pattern found through patience, a memory stretched across generations. For a very long time, eclipses must have seemed both familiar and unpredictable. People could tell that they returned, but not in a simple monthly rhythm. A lunar eclipse might appear, then vanish from experience for a while, then return years later with a strangely similar character. To notice that kind of repetition, people had to do more than look up. They had to remember, record, compare, and keep trusting that the sky might be repeating itself in a deeper way. That long attention led to one of the most beautiful discoveries in early astronomy. After about 18 years, 11 days, and 8 hours, the Sun, Earth, and Moon returned to nearly the same geometry. That does not mean everything is perfectly identical, but it does mean that very similar eclipses can happen again after that long interval. A lunar eclipse in one era may have a kind of descendant nearly 2 decades later, shaped by almost the same arrangement of shadow, light, and alignment. This repeating interval became known as the Saros cycle. The name itself came later, but the recognition of the pattern is often linked to Babylonian sky watchers, whose careful eclipse records made that discovery possible. They did not have modern physics in the form we do today, but they had something just as important at the beginning: consistency. They watched eclipses, they recorded them, they compared them, and over long stretches of time, they noticed that the sky was not improvising. It was returning. That is what makes the Saros feel so gentle and so profound at the same time. It is not a dramatic secret. It is a quiet one. It tells us that eclipses are part of a larger rhythm, one slow enough that human beings had to become historians of the sky in order to notice it. And the pattern is only nearly repeating, not perfectly repeating in place. That extra 8 hours matters. Because Earth keeps turning, an eclipse that belongs to the same Saros family will often be visible from a different part of the world. The geometry is very similar, but the planet has rotated farther by the time the cycle completes. So the eclipse may return in form without returning to the exact same sky for the exact same people. That detail makes the cycle even more interesting. The sky repeats, but with a drift. It remembers, but not rigidly. Each member of a Saros family resembles the others, yet each one still belongs to its own moment on Earth. A culture in one century may see an eclipse that echoes one seen elsewhere many years before. The family likeness is there, even when the audience changes. This kind of pattern changed more than astronomy. It changed philosophy. Once people realized that eclipses could recur in long cycles, the sky began to feel different. It still held wonder, but it no longer felt ruled only by surprise. The heavens were not acting out moods. They were not sending one-time interruptions without structure. They were following a hidden regularity that patient people could discover. That realization is hard to overstate. It meant the sky had order deep enough to outlast a single life. It meant that human beings, by watching carefully enough, could begin to stand inside that order rather than only react to it. A lunar eclipse might still feel strange and powerful, but it no longer belonged only to fear or omen. It belonged to recurrence. And recurrence has a calming effect on the mind. What repeats can be studied. What can be studied can be anticipated. And what can be anticipated begins to change its role in human life. The eclipse did not lose its beauty. It did not lose its mystery entirely. But it gained another quality. It became dependable in principle. Not every detail, not every location, not every appearance, but dependable enough to show that the heavens had memory-like regularity. The eclipse was no longer only an event. It was part of a family, part of a sequence, part of a sky that could remember itself across time. Once eclipses could be anticipated, they changed from shocks into tools. They could help measure time itself. An eclipse is dramatic, but it is also precise. That precision gave it a second life in human history. To someone standing outside under a darkening moon, a lunar eclipse can feel emotional, strange, even a little unreal. But to a careful observer, it is also something else. It is a timestamp written across the sky. That is what made eclipses so useful. Most nights are hard to tell apart from a great distance in time. A clear night in one year can look very much like a clear night in another. Even a normal full moon, though beautiful, returns too often to stand out on its own. But a lunar eclipse is different. It is rare enough to be remembered, distinct enough to describe, and structured enough to calculate later. That combination makes it unusually valuable. If an old text says that a ruler took the throne not long before a lunar eclipse, or that a battle happened in the same season as a darkened moon, that record can sometimes be anchored far more securely than an ordinary date. The eclipse becomes a fixed point. It gives historians and astronomers something to work with. In that sense, a lunar eclipse is almost like a pin pushed into time. It marks a moment that can be checked from more than one direction. People can calculate forward to predict eclipses. They can also calculate backward to identify ones already recorded. And when those calculations line up with written history, the past becomes a little clearer. This is why eclipse records became so important to rulers, scribes, and astronomers. For rulers, an eclipse could matter because it seemed significant. It might be treated as a warning or omen. But for scribes and later scholars, it also mattered because it could help place events in sequence. A rare celestial event is easier to identify in hindsight than an ordinary evening. If someone wrote that the moon was eclipsed during the reign of a certain king, that detail could later help connect that reign to a more exact point in time. That gave eclipses a lasting value far beyond the night they appeared. The shadow passed, the moon returned, but the record remained useful. Over time, this helped turn eclipses into tools of chronology. They could help anchor timelines, test the accuracy of records, and connect one historical account to another. In some cases, a single well-described eclipse became one of the strongest clues available for dating an ancient event. There is something beautiful about that. A moment that once frightened people could later help organize memory itself. The same event that might have been met with ritual noise or anxious watching could, generations later, become part of the quiet work of scholarship. The eclipse moved from omen to observation, and then from observation to reference point. That does not mean the emotional side disappeared. A lunar eclipse could still feel charged with meaning, even while becoming useful as a measure of time. Human beings are very good at living with more than one layer of understanding at once. Something can feel sacred and practical. It can be symbolic and measurable. A darkened moon could still stir the imagination, while also serving as a reliable marker in a written record. And that is one reason eclipses sit so comfortably between science and culture. They are memorable enough for story. They are regular enough for astronomy. They are specific enough for history. Few sky events do all three so well. There is also a deeper idea hidden inside all of this. For an eclipse to help measure time, the heavens must be stable enough to trust. The motions of the Earth, Moon, and Sun must be orderly enough that a rare event can be traced across centuries. That means every eclipse used in history is also quiet evidence of something larger. The sky keeps its promises. Not in a human way, of course. Not with intention, but with regularity. The same motions that once seemed mysterious prove steady enough for people to build calendars, compare old records, and reach back into time with surprising confidence. So the lunar eclipse became more than a spectacle. It became a bridge between one generation and another, a bridge between a written line on an old tablet and a real event in the sky, a bridge between fear and measurement, between wonder and record keeping. And that may be one of the most peaceful things about it. The eclipse does not have to lose its beauty in order to become useful. In fact, it becomes even more interesting when it does both at once. It can still hush a crowd, still pull eyes upward, still tint the moon with that strange old red. And at the same time, it can sit quietly inside a calendar, helping people place themselves in the long flow of time. Yet even where prediction grew, symbolic meaning did not disappear. In India especially, myth and celestial pattern lived side by side. In the Indian tradition, eclipses were given one of the most vivid stories in the sky. The story is about Rahu and Ketu. In its most familiar form, Rahu is linked to a being who tried to take part in divine immortality and was cut apart, leaving behind a head and a body separated from one another. From that story came two powerful figures: Rahu, often associated with the head, and Ketu, associated with what remained. In later tradition, they became deeply tied to eclipses, to those moments when the sun or moon seems to be swallowed for a time. It is a striking image. A bright body in the sky is suddenly overtaken. The familiar becomes threatened. The heavens seem to enter a brief moment of disorder. That kind of story gives the eclipse shape in the human imagination. It turns a shadow into a drama. It gives people a way to feel the event, not just witness it. And that matters because a lunar eclipse is not only a technical alignment, it is also a visual and emotional experience. The moon changes slowly, but unmistakably. It feels like something is happening to it. A story like Rahu and Ketu meets that feeling directly. It tells the eclipse in the language of action and character. But what makes the Indian tradition especially rich is that this symbolic meaning did not have to erase the pattern in the sky. The story could live alongside observation. That is one of the most interesting things about the history of eclipses in India. Myth and system were not always enemies. They could exist together, each doing different work. The myth gave emotional and symbolic form to the event. It made the eclipse memorable, meaningful, and culturally alive. At the same time, Indian astronomy also developed sophisticated ways of tracking celestial motion and understanding repeating alignments. So the eclipse could be both storied and structured. It could belong to ritual meaning and also to careful sky knowledge. Over time, Rahu and Ketu were not only mythic beings. In astronomical thought, they also came to be associated with the lunar nodes, the crossing points where the moon's tilted orbit meets the flatter plane of Earth's path around the sun. Those crossing points are exactly the places that matter for eclipses. If a full moon happens near one of them, a lunar eclipse becomes possible. That connection is beautiful in its own way. A symbolic figure and a geometric reality begin to overlap. The myth is not the same thing as the astronomy. It is important not to flatten one into the other. But the fact that these ideas could sit in the same tradition shows something important about human culture. People do not always choose between meaning and mechanism in the simple way we sometimes imagine. Very often, they carry both. One tells them what an event feels like. The other tells them how it happens. And both answers can matter. That is why this part of the story deserves a respectful tone. It is too simple to say that myth was merely confusion waiting to be corrected. Myth was often a way of holding awe, fear, and wonder together in a form people could remember. It connected rare events in the sky to moral, spiritual, and cultural life. It gave the eclipse a place in the human world. Science, by contrast, gives the eclipse a place in the physical world. Both are forms of understanding, though they answer different questions. The story of Rahu and Ketu asks, in part, what kind of event this feels like, what kind of disturbance it resembles, what kind of meaning it carries. Astronomy asks where the moon is, where the earth is, where the sun is, and how their paths cross. Neither question cancels the other. In fact, when we look back at eclipse traditions, It is often more honest to say that human beings were layered in their understanding. They felt the drama of the event and also noticed its order. They told stories about the moon being overtaken and also learned, slowly and carefully, that eclipses belong to repeating alignments. That balance can feel very peaceful. It reminds us that human beings have always looked upward with more than one kind of attention. We do not only calculate, we also imagine. We do not only explain, we also respond. A lunar eclipse is one of those rare events that seems to invite both habits at once. The moon darkens, the old stories rise, the geometry remains true. And when both meaning and mechanism are held gently together, another helpful truth comes into view. Not every lunar eclipse looks the same. Some are faint. Some are dramatic. Some barely dim the moon at all, while others carry it deep into shadow. Not every lunar eclipse looks dramatic. Some are easy to miss. Some are impossible to ignore. And some unfold so gently that a person might look up, see the moon, and not realize an eclipse is already underway. That is because lunar eclipses come in different forms, depending on how deeply the moon passes into Earth's shadow. The full moon does not always take the same path through the shadow. Sometimes it moves only through the faint outer edge. Sometimes it brushes the darker center. And sometimes it passes so deeply into that central shadow that the whole moon changes color and character. The gentlest kind is called a penumbral lunar eclipse. In this case, the moon passes only through Earth's penumbra, the lighter outer part of the shadow. Because the penumbra does not block the sun's light completely, the effect can be very subtle. The moon may look a little dimmer, a little grayer, or slightly shaded on one side, but the change can be hard to notice unless you are watching carefully or comparing it to photographs. A penumbral eclipse is still real. The moon is still entering Earth's shadow. It is just entering the softer part. That softness matters because it helps explain why some eclipses may have gone under-recorded in the past. If a culture did not know to watch for the event, or if the dimming was slight, a penumbral eclipse might pass with little attention. A bright full moon that looks only a touch muted does not always announce itself clearly. The next kind is a partial lunar eclipse. This happens when part of the moon enters Earth's darker central shadow, the umbra, while the rest remains outside it. This is the stage many people picture most easily. A clear, curved darkness begins to move across the face of the moon, making it look as though a smooth bite has been taken from it. The effect is much more obvious than in a penumbral eclipse. Now the shadow has weight. Now the shape is unmistakable. Now the event truly feels like a visible crossing. During a partial eclipse, the moon can appear divided between brightness and shadow, with one side still glowing and the other sinking into darkness. It is one of the clearest demonstrations that the eclipse is not caused by cloud, weather, or some blur in the air. The edge of the shadow is too clean, too curved, too steady. Then there is the total lunar eclipse. This is the most complete form. The entire moon enters the umbra, Earth's deepest shadow. It does not usually disappear entirely, because some filtered reddish light from Earth's atmosphere still reaches it. That is when the moon can turn copper, rust, brown red, or a deeper blood-like shade. A total lunar eclipse is the version most likely to stay in memory. The whole moon is changed. The night feels altered. The familiar becomes strange. And because total eclipses are the most visually dramatic, they are often the ones most strongly preserved in story, record, and collective memory. These three forms, penumbral, partial, and total, are not separate kinds of moon. They are different experiences created by different depths of shadow. The moon remains the same object. What changes is how far into Earth's shadow it travels. That detail matters historically as well as scientifically. What people recorded in the past depended greatly on what they actually saw. A culture observing a strong total eclipse would likely respond very differently than one encountering a faint penumbral one. The deeper the moon moved into shadow, the more obvious the event became, and the more likely it was to be described, remembered, and interpreted. This means the history of eclipses is shaped partly by visibility itself. The boldest eclipses leave the loudest footprints in human memory. That is one reason total lunar eclipses appear so often in stories, omens, and historical records. They are harder to ignore. They transform the whole moon, not just a corner of it. By contrast, subtle eclipses could slip by with much less notice, especially in times or places without a strong tradition of careful sky observation. So when we speak about lunar eclipses as though they are one single experience, it helps to remember that the sky offers variations. Sometimes the moon only brushes the shadow. Sometimes it enters halfway. Sometimes it sinks all the way in. Understanding those categories is useful because it shows that not all eclipses feel the same from the ground. Some are technical events more than emotional ones. Others are visual enough to stop people in their tracks. But even names and categories can only carry the story so far. To really understand a lunar eclipse, it helps to step outside the language for a moment and return to the experience itself. What does it actually feel like to stand under the night sky and watch the shadow move, minute by minute, across the face of the moon? A lunar eclipse is not the kind of event that rushes at you. It does not burst into the sky all at once. It does not demand panic. It does not force the eyes to keep up with something fast. Instead, it arrives in a slower way. You step outside, look up, and the moon seems almost normal at first. Maybe a little duller, maybe a little less bright than you expected. If the eclipse has already begun, the change can be so gentle that it takes a moment to trust what you are seeing. Then, as the minutes pass, the difference becomes clearer. A shadow is moving. That is one of the most unusual parts of a lunar eclipse. You are not just looking at the moon, you are watching a process. The night sky, which often feels still and unchanging from one glance to the next, suddenly becomes something you can follow in real time. The shadow does not leap, it creeps. It edges across the moon little by little, so slowly that no single second feels dramatic, and yet every few minutes the moon looks different from before. That gives the whole event a patient kind of power. The eclipse unfolds on a human timescale, slow enough for a person to stand there, breathe, think, and simply remain with it. That pacing changes the mood completely. A meteor flashes and is gone. A lightning bolt strikes in an instant. But a lunar eclipse stays. It gives people time to settle into it. That is why the experience can feel so calm, even though the event itself is rare and strange. The eclipse does not shout. It lingers. It lets the eye adjust to each stage. It lets the mind return to the moon again and again, noticing how much more of it has darkened since the last glance. Often, the event stretches across hours rather than moments. That long duration matters. It means a person does not have to freeze in place and stare without moving. A lunar eclipse invites a softer kind of attention. You can stand outside for a while, go back in, return later, and still find the event continuing. You can watch alone in silence, or with other people nearby. You can speak quietly, then stop speaking, then look up again. The eclipse leaves room for ordinary human life to move around it. And yet, it keeps pulling the eye back. There is something about the moon changing that makes people want to check on it, almost the way you might glance toward a fire across a dark field. You know it is there. You know it is changing. And each return glance gives you a slightly different scene. At first, the drama comes from the shadow. Later, if the eclipse deepens enough, the drama comes from the color. The moon can begin to glow with that deepened red or copper tone, and even then the experience remains softer than the color itself might suggest. The red is striking, but the event is still quiet. The moon is changed, but the sky is not violent. It is more like the familiar has drifted into another state for a little while. That combination is part of what makes lunar eclipses feel so memorable. They are dramatic without being harsh. You can imagine how many generations of people have stood under the same slow darkening and felt the same pull to keep watching. A person in the modern world, someone in an ancient city, someone in a village thousands of years ago, all could have shared that basic experience. The details of what they believed might differ, but the visual rhythm would feel familiar across time. The moon bright, the shadow arriving, the shape changing, the color deepening, the long wait while the night holds still around it. There is something deeply human in that kind of shared watching. It is not only that the eclipse is visible, it is that it is visible slowly. It allows people to remain present with it. It creates a kind of natural pause, a reason to step out of routine and let the night take on a little more meaning than usual. And maybe that is why lunar eclipses stay with people so well. They do not just show something rare. They create a mood around it. The mood is patient. The mood is watchful. The mood is strangely peaceful, even while the moon itself is being transformed. That slowness is part of what makes lunar eclipses feel so different from solar eclipses, which tend to strike harder and vanish faster. A lunar eclipse can be awe-inspiring, but it is rarely harsh. Its geometry makes it calm. That may sound strange at first, because an eclipse is still an eclipse. The moon is entering shadow. The sky is changing. Something rare is happening overhead. But the feeling of a lunar eclipse is very different from the feeling of a solar eclipse, and much of that difference comes from scale. Earth's shadow is large, much larger than the moon itself. So when the moon begins to move into that shadow, it does not vanish all at once. It takes time. The moon crosses into the penumbra first, then deeper into the umbra, and the whole process unfolds gradually. The shadow is wide enough to let the change happen in stages, which stretches the event out and softens its mood. That is one reason a lunar eclipse feels so patient. The geometry gives it room. Nothing in the event is rushed. The moon is not being covered by a tiny moving object that slices across it quickly. It is passing into a broad shadow cast by an entire planet. That makes the eclipse feel more like a slow drift than a sudden interruption. And because the moon is only reflecting sunlight, there is no danger in looking at it during an eclipse. That is another part of what makes the event feel gentle. A solar eclipse asks for caution. The sun remains intensely bright even when part of it is covered, and looking directly at it the wrong way can harm the eyes. A lunar eclipse has none of that tension. You can simply look up. No special glasses are needed. No protective filter is required. The event invites direct observation in the most natural way possible. This changes the emotional tone immediately. A lunar eclipse is not an event people have to brace themselves for. It is one they can settle into. There is no warning not to look too long. There is no fear of damaging the eyes by watching it unfold. The moon remains a safe object to gaze at, even while it is changing. That sense of ease matters more than it might seem. It means the eclipse feels open rather than restricted. Anyone who happens to be on the night side of Earth, with the moon above the horizon and the sky clear enough to see it, can potentially be part of the experience. You do not have to be in a narrow path. You do not have to travel to a single perfect location. The event belongs to a huge region of the world at once. That is very different from a solar eclipse. A solar eclipse is usually more localized. Its path of totality is narrow, its darkness more sudden, its emotional effect often sharper and more intense. A solar eclipse can feel like the daytime world has been interrupted in a dramatic way. The light drops, the temperature may change, the world takes on an unfamiliar tone very quickly. A lunar eclipse moves in the opposite direction. It belongs to the night already. It darkens something that was bright, rather than dimming the whole world. It changes the sky without seizing the landscape. That is why it can feel more communal in a softer way. People across a large portion of Earth can share the same event, each under their own sky, each looking at the same moon. Families can watch from backyards. Friends can drift in and out of the experience. One person may watch for 10 minutes, another for an hour, another only long enough to catch the red glow near totality. The event allows for that kind of shared looseness. It does not demand perfect stillness or perfect timing from the watcher. It welcomes return glances. It welcomes quiet conversation. It welcomes patience. And that patience is built right into the mechanics of the event. Earth's shadow is large enough to make the eclipse slow. The moon is safe enough to watch directly. The visibility is wide enough to include many people at once. All of those features shape the experience before anyone even begins to interpret it. So when people describe a lunar eclipse as peaceful, they are not only describing their mood, they are describing the geometry. The science itself produces the softness. The event is calm because of how big Earth's shadow is, how the moon reflects light, and how broadly the eclipse can be seen across the night side of the planet. The gentle feeling is not separate from the physics. It comes from it. And that is part of what makes lunar eclipses so special. They are scientifically exact, yet emotionally easy to be with. They can still stir awe, but they do not crowd the watcher. They unfold in a way that feels almost considerate. safe and gentle does not mean scientifically empty. Even now, eclipses still tell scientists things about Earth and its atmosphere. Modern science did not outgrow lunar eclipses. It found new uses for them. Even now, when people already understand the basic geometry of the event, a lunar eclipse is still more than something beautiful to watch. It is still a kind of natural experiment. The moon enters Earth's shadow, the light changes, and for a little while the sky offers scientists a rare chance to study our own planet in an unusual way. That may sound surprising at first. After all, the moon is the object changing in front of our eyes. It is the thing growing dark, then red, then slowly bright again. But during totality, the light reaching the moon is not ordinary moonlight. It is sunlight that has passed through the edge of Earth's atmosphere before bending into the shadow. That means the eclipsed moon is carrying information. The light arriving there has already traveled through layers of air, through gas, haze, and sometimes dust. It has been filtered by Earth before it ever touches the lunar surface. Then the moon reflects that altered light back toward us. So when scientists study the light coming from an eclipsed moon, they are not only studying the moon, they are also studying Earth. This is one of the quiet scientific gifts of a lunar eclipse. Earth's atmosphere leaves its fingerprints in the light. Certain gases absorb specific parts of the spectrum, which means scientists can look for faint patterns in that filtered glow. Those patterns are called absorption features. They act like small missing pieces in the light, and they can reveal what kinds of molecules the light passed through on its way to the moon. In this way, a lunar eclipse can help scientists detect signs of things like oxygen and water vapor in Earth's atmosphere. That is a remarkable idea when you slow down and think about it. The moon becomes a distant mirror. The atmosphere becomes the filter. And the eclipse becomes a way of reading the air around our own world. There is another reason this matters. Astronomers often study faraway planets by watching light pass through their atmospheres. When a planet crosses in front of its star, a small amount of starlight filters through the planet's air before reaching our telescopes. By studying how that light changes, scientists can learn something about the planet's atmosphere. A lunar eclipse creates a similar kind of situation much closer to home. During totality, sunlight passes through Earth's atmosphere, bends into the shadow, lights the moon, and then travels back to observers. In a way, Earth is behaving like an exoplanet in that moment. Scientists can use the eclipse to practice reading an atmosphere through filtered light, which helps them improve the same methods used to study distant worlds. So a lunar eclipse is not only about the moon turning red. It is also a local example of a much larger idea in astronomy. How do you learn about a world you cannot touch directly? You study the light that passed through it. That gives lunar eclipses a scientific role that feels both modern and elegant. A sky event, once feared as an omen, now helps researchers refine the tools used to search for atmospheres far beyond Earth. And the eclipse can reveal other things too. Because the red light reaching the moon has traveled through Earth's atmosphere, the eclipse can carry clues about how clear or dusty that atmosphere is. If the air is filled with more particles than usual, the light may be dimmer or altered in color. If the atmosphere is clearer, the eclipsed moon may glow more brightly. Even clouds and haze in lower parts of the atmosphere can influence how much light makes it through. So the eclipse is not only a lesson in shadow, it is also a kind of atmospheric report. Not a simple one, and not complete on its own, but still a real one. The moon's appearance during totality can reflect changing conditions in the air around our planet. That means each eclipse is shaped not only by the geometry of Earth, Moon and Sun, but also by the current state of Earth's atmosphere itself. That is why a lunar eclipse is still scientifically alive. It is calm enough to watch for beauty and rich enough to study for evidence. The same event that softens the moon for the eye also carries subtle data in the light. It remains, even now, both a scene and a measurement. And once you know the atmosphere is part of the story, another question follows naturally. Why are some eclipses vivid and glowing, while others seem dim and brown or nearly lost? Not all red moons are equally red. Some glow like copper, some look soft and amber, some seem darker, browner, almost smoky, and some are so dim that the moon can look nearly lost in the sky. That difference is one of the most interesting things about a total lunar eclipse. The event may follow the same basic pattern each time, but the appearance can vary quite a lot. The reason is that the moon is not being lit only by shadow. It is being lit by sunlight that has passed through Earth's atmosphere first. And Earth's atmosphere is never exactly the same from one eclipse to the next. Some nights, the air lets more filtered reddish light bend into the shadow. Other times, less light makes it through, or the light is altered more strongly along the way. That means the look of the eclipse moon depends not only on the positions of the Sun, Earth, and Moon, but also on the current condition of the air surrounding our planet. In that sense, a lunar eclipse is partly a portrait of Earth's atmosphere projected onto the moon. If the atmosphere is relatively clear, the moon may appear brighter during totality. It can glow with a warm copper or orange-red tone, sometimes vivid enough to stand out strongly against the dark sky. But if the atmosphere holds more dust, haze, or other tiny particles, the moon may look much darker. More light gets scattered or absorbed before it can bend into Earth's shadow and reach the lunar surface. That is why total lunar eclipses do not all have the same mood. Some feel bright and dramatic. Some feel muted and heavy. Some seem almost ghostly. Dust plays a major role here. So do volcanic aerosols, tiny particles thrown high into the atmosphere by major eruptions. These particles can linger for months or even longer, spreading around the globe and changing how sunlight moves through the air. When that happens, less of the warm, filtered light may reach the moon during an eclipse, and the eclipse moon can become unusually dark. Haze can matter too. So can broad atmospheric conditions. Even the overall clarity of the air around the world becomes part of the event. Cloud patterns also shape what kinds of light pass through different parts of the atmosphere, though the story there is more complicated. The main idea is simple enough. The moon's color during totality depends on how Earth's atmosphere handles sunlight at that moment in history. Astronomers even have a gentle way of describing these differences. It is called the Danjon scale. This scale gives a rough sense of how bright or dark a total lunar eclipse appears. At the darkest end are eclipses where the moon is so dim it can be hard to see, almost disappearing into the night. Farther up the scale are eclipses that look deep brownish red or rusty. Brighter ones may appear brick red, coppery, or even orange, with clearer details still visible on the moon's surface. The Danjan scale is not about perfect measurement in the strictest sense. It is more of an observational guide, a way of describing the character of the eclipse as seen by human eyes. Still, it gives language to something sky watchers have long noticed. The red moon changes its personality from one eclipse to another. One of the strongest modern examples came after the eruption of Mount Pinatubo in 1991. That eruption sent enormous amounts of material into the atmosphere. In the years that followed, some lunar eclipses were observed to be exceptionally dark. The moon did not shine with the usual copper glow so easily. Instead, it could look much dimmer, more subdued, as if the atmosphere had taken away much of the light that normally filters through. That example is helpful because it makes the connection very clear. A volcanic eruption on Earth can change how the eclipse moon looks. The moon, in that moment, becomes less like an isolated object and more like a surface carrying information from our own planet. It reflects the condition of the air around Earth back to us in a visible way. During totality, the moon is telling two stories at once. One about celestial alignment, and one about the atmosphere of the world beneath it. That is part of what makes the event so rich. We watch the moon, but Earth is present in the color. We follow the shadow, but the air decides how that shadow is lit. So when one eclipse glows bright red and another seems dark and bruised, the difference is not random. It is part of the physics of filtered light, shaped by gases, particles, dust, and the ever-changing condition of Earth's atmosphere. The moon may be the object we watch, but in a sense we are also watching Earth. And because so many people can witness it at once, the event becomes a shared experience on a planetary scale. One of the quiet beauties of a lunar eclipse is that it is not only personal, it is shared. A person can step outside into a backyard, onto a balcony, into a field, or beside a quiet road. Look up and see the same changing moon that many other people are seeing at that very moment. Not the same kind of moon, the same moon, the same shadow, the same slow darkening moving across its face. That gives a lunar eclipse a special feeling. It can feel private because the night around you is local. The air has its own temperature. The trees have their own shape. The sounds near you belong to your place alone. Maybe there is a soft wind. Maybe there are distant cars. Maybe the whole neighborhood is quiet. Your part of the experience belongs only to where you are. And yet, above all of that local life is one shared event. The moon changing for many people at once. Anyone on the night side of Earth, with the moon above the horizon and the sky clear enough to see it, can become part of the same moment. That is very different from many other rare sights in nature. Some events belong to one valley, one coast, one mountain, one storm. A lunar eclipse belongs to a huge portion of the planet at the same time. That wide visibility matters. It means the eclipse can feel both intimate and communal. A person may watch it alone and still be part of something larger. Families may stand outside together. Friends may text each other from different cities. Photographers may set up cameras in one country, while people somewhere else simply pause on a walk home and look up. Ancient communities once watched it from courtyards and open fields. Modern observers watch from rooftops, parks, and apartment windows. The settings change, but the act is the same. People look up. They notice the moon changing. They keep watching. There is something deeply human in that repetition. A lunar eclipse creates a brief tradition shared across time as much as across space. It joins people who know a great deal about astronomy with people who know almost nothing about it. It joins children seeing their first eclipse with older people who may remember one from years before. It joins careful sky watchers with people who just happen to glance up at the right time. The event does not ask for much. It asks for darkness. It asks for a view of the moon. It asks for a little patience. And because of that, it remains one of the most accessible wonders in the sky. You do not need to understand the orbital details to feel its strangeness. You do not need special equipment to see the shadow. The moon is large enough, bright enough, and familiar enough that its change speaks for itself. This is part of why lunar eclipses have stayed culturally powerful for so long. They are easy to share. A red or shadowed moon becomes a common point of attention. It gives different people, in different places, something simple and unmistakable to notice together. Even when beliefs differ, even when languages differ, the sight itself is still there. A darkened moon is understandable before it is explained. It reaches the eye first, then the emotions, then the mind. And the shared nature of the event makes the moon feel strangely close. Most of the time, the moon can seem distant in a quiet, ordinary way. It rises, it shines, it changes shape across the month, and we accept it as part of the background rhythm of life. But during an eclipse, it becomes active again in human attention. People speak about it, plan around it, step outside for it, wait for clouds to pass so they can see it. For a little while, the moon becomes social. Not because it changes what it is, but because it gathers attention from so many places at once. That is a lovely thing to remember. Across towns and fields, across coastlines and cities, across mountains and open plains, many people may be standing under different skies, feeling different air, hearing different sounds, and yet all of them are watching the same shadow cross the same old moon. Local life remains different everywhere, but overhead the event is shared. That communal view reveals something deeper too. The eclipse feels broad and connected, because the system behind it is broad and connected. The moon can only be shared in this way, because the Earth, moon, and sun keep moving with extraordinary steadiness, holding their long relationship across time. By this point, the lunar eclipse can begin to feel less like a single event and more like the visible surface of a much larger relationship. Because that is what it is. The eclipse is not one isolated trick of light. It is not a rare accident that appears out of nowhere. It is the result of three bodies moving together in space in a steady and lawful way. The sun, the earth, the moon. We often speak about them one at a time because that makes them easier to understand. But a lunar eclipse reminds us that they are not separate stories. They are one system in motion. The sun is the source of the light. The earth moves through that light. The moon circles Earth and reflects the sunlight back to us. Most of the time, we see only pieces of this relationship. We notice the moon's changing phases. We notice the daylight of the sun. We do not always feel the system as a whole, but during a lunar eclipse, the larger arrangement becomes visible in a way that even an ordinary observer can sense. The full moon is the first part of that arrangement. The moon has to be on the far side of Earth from the sun. That is why a lunar eclipse can only happen at full moon. But as we have already seen, the full moon alone is not enough. The moon's path around Earth is tilted slightly, so most full moons pass above or below Earth's shadow. That means the eclipse depends on a second condition. The alignment has to be exact enough. The full moon must arrive near the place where the moon's tilted orbit crosses the flatter plane of Earth's path around the sun. Only then does the moon move into the shadow instead of missing it. Only then does the hidden geometry of the system show itself so clearly in the sky. And then there is the shadow itself. Earth does not simply block the light in a vague way. It casts a shadow with structure. There is the faint penumbra on the outside and the deeper umbra at the center. The moon can pass through one or both of these regions, which is why eclipses can be penumbral, partial, or total. So even the shadow has layers. The event is built from light, position, angle, and motion all working together. That is part of what makes a lunar eclipse such a powerful teaching moment. You do not need a diagram on paper to understand that something real is happening between worlds. You can see it. You can watch the curved darkness cross the moon. You can notice the red light that has come through Earth's atmosphere. You can follow the slow timing of the event and feel that it belongs to a larger order. In that sense, a lunar eclipse is one of the clearest visible lessons in astronomy. It lets people see orbital mechanics with their own eyes. Usually, orbital motion feels abstract. We are told that the Earth moves around the sun. We are told that the moon moves around Earth. We understand it in words. But during an eclipse, those motions become visible in consequence. The system leaves a mark. The geometry draws itself across the moon. That is a rare thing. So much of space is too large, too slow, or too distant for human beings to feel directly. But the lunar eclipse brings a piece of that cosmic structure close enough to watch from a backyard. It takes something enormous and translates it into a visible sequence. The moon dims, the shadow curves, the color changes, the alignment reveals itself. And all of it happens because the system is working exactly as it should. That may be the calmest truth in the whole story. Nothing about the eclipse is chaotic. Nothing has gone wrong. The event looks strange because the geometry is so exact, not because it is broken. The moon is still following its path. Earth is still following its own. The sun is still sending light outward in every direction. The eclipse happens when those steady realities briefly arrange themselves in just the right way for human eyes to see the relationship clearly. That is why the event can feel both intimate and cosmic at once. It is intimate because the moon is familiar. It has always belonged to ordinary human life, rising over homes, rivers, roads, and sleeping towns. But it is cosmic because, during the eclipse, that familiar moon carries evidence of something much larger than itself. It becomes proof of a system wide enough to include our planet, our atmosphere, and the light of the sun all at once. And then, after all the meaning, all the shadow, and all the explanation, the moment passes. The moon returns. At some point, the deepest part of the eclipse begins to loosen. The dark shadow that had seemed to take hold of the moon starts to pull away. The curved edge moves on. The red begins to thin. The old brightness slowly returns. And just as the eclipse arrived gradually, it leaves gradually too. There is no sudden switch, no sharp ending, no dramatic snap back to normal. Instead, the moon eases out of shadow the way it entered it, with patience. A brighter edge appears first. Then more of the familiar pale surface comes back into view. The reddish glow fades into grey, then silver, and slowly the moon becomes itself again. Or at least it seems to. Because after watching an eclipse, the moon does not feel quite as ordinary as it did before. It is still the same moon, of course. Still travelling its old path. Still rising and setting over the earth as it always has. But for a little while, the eclipse lets us see that familiar object in a different way. It reminds us that even the most familiar things in the sky are part of larger motions, larger patterns, and larger relationships than we usually feel from day to day. That may be one of the loveliest things about a lunar eclipse. It does not take the moon away from us. It gives the moon back with more meaning. Long ago, people may have watched the returning light with relief. If the moon had seemed threatened, then its recovery would have felt like a restoration. The danger had passed. The order of the sky had returned. The familiar world was steady again. Today, the feeling may be different, but it is not entirely separate from that older one. We may understand the geometry now. We may know about the alignment of the sun, earth, and moon. We may know about orbital tilt, the shape of Earth's shadow, and the red light filtered through the atmosphere. But understanding does not flatten the event. If anything, it deepens it. The eclipse becomes more than a strange sight. It becomes a visible meeting of shadow, light, motion, and time. It becomes a reminder that the world is not only beautiful, but structured. Not only mysterious, but understandable in a way that makes the mystery calmer rather than smaller. That is an important distinction. Sometimes people imagine that explanation takes wonder away, but a lunar eclipse suggests the opposite. The more we understand it, the more layered it becomes. The ancient fear, the human stories, the patient records, the geometry, the atmosphere, the shared watching across continents, all of it remains there together. The moon returns to brightness, but the meaning lingers. And the cycle itself goes on. The moon will continue circling Earth. Earth will continue circling the sun. The orbit will remain tilted. The shadow will keep forming. And in time, when the alignment comes right again, another eclipse will arrive. That continuity is deeply calming. The eclipse is rare enough to feel special, but regular enough to belong to the world's ongoing rhythm. It is not a break in nature. It is one expression of nature's steadiness. The shadow comes, the shadow goes. The moon dims, the moon brightens. The system continues. And maybe that is why the ending of a lunar eclipse feels so peaceful. Nothing has been lost. The moon has not been harmed. The sky has not been broken. The light has not disappeared forever. What we have seen is a passing arrangement, a moment when the hidden order of the Earth-Moon-Sun system became visible for a while and then gently moved on. So the moon brightens, the night settles, the old familiar look returns. But perhaps the listener does not return in exactly the same way. Because once you have watched the earth cast its shadow onto the moon, once you have seen that red glow carrying the filtered light of our own atmosphere, once you have felt how ancient and shared this experience really is, the sky can seem a little larger afterward. Not colder, not more distant, just larger, and also closer somehow. A lunar eclipse does that so well. It shows us our place in the system without making that place feel small in a lonely way. It reminds us that we live inside motions vast enough to shape the heavens, and yet gentle enough to be watched in silence from a backyard, a window, a quiet road, or an open field. The shadow passes, the moon returns, and what remains is a quieter kind of awe. The feeling that the sky is understandable, beautiful, and still large enough to humble us.